Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and manufacturing. In today's episode, Jonathan Scott and Jen Farello break down the walls around PDM versus PLM, product data management versus product lifecycle management. While there is overlap between the two, they both have different purposes. They discuss the evolution of the two systems and how they can best serve an organization. And here's Jonathan and Jen.
All right, and welcome to the podcast, Stay Sharp with Razorleaf. My name's Jonathan Scott, and I've got Jen Farello here with me.
Hi there.
And we are back talking about all things digital related to products and manufacturing. And what we want to get into today is maybe two of the most common and maybe even confused acronyms that we hear about in the work that we do regularly. That's PDM and PLM. Those should be fun ones to talk about today. What do you think, Jen?
I think it's a good idea to talk about these because there is a bigger difference than just the letter. It's what we were laughing about a little bit earlier.
Mm-hmm.
We can start there, right? I mean, it's, product data management versus product lifecycle management. Some of it's in the words as far as, the scope and the definition. But PDM came first, in my estimation.
Yep.
It's where it seemed like we started with CAD data and engineers and needing to control that data. But it's certainly gone a lot further than that.
I think that's right. Yeah. And, like you said, just one letter, but what's the difference? There's a big difference, I think, in terms of what they deal with. And I think that's a good place. What you just mentioned is a good place to dig into it is, well, where did it come from? And what does that tell us? Where did each of them come from? And what does that tell us about the difference between them? And the letters and the words, they're data and life cycle. I struggle with how that really describes how they're different. But let me jump into what I think about where PDM came from. Just like you said, from CAD file management, from that history, what does that tell us about what it does versus what PLM might do? And I'll give you my view on the history is, like you said, it came from trying to manage CAD files because a lot of CAD modeling or 3D CAD systems, they came up with some innovations that caused some problems in terms of managing their data. So if I think back to maybe late 90s, something like that, the CAD systems that we were dealing with, the 3D stuff had been around for a bit in some of the higher end CAD tools. But in terms of how they were dealing with those pieces of 3D, things like assembly modeling were still early days in terms of how those were behaving. And we didn't have the kind of clarity that I think a lot of folks have today when they deal with CAD tools, where there's a specific file type for a part, and that's a different file type than for an assembly, where you collect up a bunch of parts and mate them together and orient them where they go and that kind of thing. And of course, I'm speaking about mechanical CAD here. That's kind of my history and background.
Mine as well. So it's an easy place to be.
Exactly. But when we were early days in those CAD tools and the 3D was really coming on, you could put everything in one file, right? Whether it was AutoCAD or CATIA or whatnot, you could stick the 3D in the same file as the 2D. You could put multiple separate bodies of 3D bodies in the same file. You could do whatever you wanted to. And then as, performance started to become an issue and you also had larger teams working on things, there was this idea of, separate out the content into different files. So, you work on the tire and I'll work on the wheel and that other person will work on the brake. So if we each had separate files, we could work independently. Now, remember, we are talking back, 90s kind of time frame when operating systems still had challenges where it's like two people work on the same file at the same time. You must be crazy. So those were the things that were going on at the time. And what it meant was, now engineers had multiple files to deal with, but they had to keep them consistent. They had to keep them linked and together because if you, made a mistake and you had, there's a copy of the old tire and there's a copy of the new tire, and maybe it's not just 2 copies, but it's 10 copies from the last 2 months where we've been working on the file, and you accidentally grabbed the wrong version of the file to put in there, now you had a problem, right? From an engineering perspective, that turns into a big problem when you lose configuration control. So to me, that's where PDM started and came from, is people recognized a need to solve that problem to say we need to keep straight the versions and all the files and how they're linked and how they relate. And with that, part of it's version control, right? So I need to tell the difference between, the file I made 3 weeks ago versus 2 weeks ago versus last week versus this week, and know which version is which and which version of that tire goes with the wheel, that kind of thing. Along with that came a need to identify which of those versions is the one I really want, or is, I'll say released. That's the connotation a lot of people have.
Right, which is the official source of truth, so to speak.
Right. What's the real one that other people should use? And with that, I'll say that's life cycle. That's going to confuse us when we talk about PLM and PDM, but maybe maturity is another good word for it, is, which version is the most mature. And it may not just be like work in process and release. It could be obsolete, could be other states too. But that's another important thing that PDM needed to bring to the table. And it's funny because each of these capabilities sort of, there's a logical extension to it. Another thing that PDM does is some kind of basic workflow, right? That lets you get from one maturity to another, because logically, when engineers looked at how does this tool help me do my job every day, they said, well, what do I do with things? Well, I get them work in process, I work on multiple versions, I find the one that I like, and then I get some review or approval, and I release it. Review and approval. Well, there's your workflow need, right? So PDMs can help us get from one version or one maturity state to another with some kind of approval or routing that lets multiple people look at it.
It's a pretty limited workflow though, right? I mean, it's simply within the engineering department.
Yeah, a lot of times it is, right? I mean, not that the tools prevented people from adding in a purchasing person, but I think in terms of what actually got used, you're exactly right. PDM, a lot of times, it's like an engineering work group kind of tool. Folks who understand the data set and what they're working with, it's sort of specialized for the experts, to your point, right? I think that's a lot of what we see. And so that means that those workflow processes were pretty simple. I think another logical extension, once people had those CAD files under control, right, and under management, one of the things that they got was a structure. So, this is maybe co-evolution of two things at once, that the CAD tools were evolving at the same time that the PDM tools were evolving to manage them. And that meant that we did start to have that differentiation between an assembly and a part, and the PDM tools would understand the assembly hierarchy of a design, which is, that product structure, that's the bill of material, right? Now, here's the part where it got interesting is the engineering bill of material is not always exactly the CAD structure. So these PDM tools added the capability for making them a little different, right? Let me take a CAD structure or a file structure and copy it or morph it or tweak it or whatever, make it a little different, to add in, grease or paint or things like that, or to subtract out sub-assemblies that maybe that's not really a sub-assembly and I just had to have it there, or a part like I've got a skeleton part for design, but it's not really a part, it's just a sketch. So that ability to have an E-BOM or engineering BOM that's similar or connected to, but a little different from a CAD structure, that's something else a lot of PDMs added. Back to your point a minute ago, because that was helpful for engineers, right? They're really the people that this tool is focused on. Now, I think another logical one is if you could already manage CAD files with versions, and they're just files, right? Except, the PDM system was good at looking inside of them to figure out how they related to other files. But if you could manage files and you could manage versions of them, and you could change their maturity to know which one is ready and released and which one's maybe superseded and you shouldn't use it, that kind of thing. Why couldn't you do that with documents? Excel files, Word documents, PDFs, things that are all the additional specifications of a product beyond the CAD and the geometry and the drawings. And so document management became a logical one.
Right. All the stuff that you might find in a technical data package or something like that.
Exactly. And it's not that there weren't enterprise systems around that could do this at the time. Lots of companies probably had, maybe a SharePoint back then, but maybe like an OpenText or a Documentum or something like that to manage documents. But again, PDM, because it was all sort of logically being built off of what the engineer needed to do with their data set, they were like, well, I just want to keep it all in one place. I'll manage my specifications right here with my bill of material and my CAD data. And to your point, it's kind of all one nice little package. If you had to make TDPs for folks, technical data packages, then you had it all in one spot. So I think those are the kinds of things that PDM grew into because each one was a logical extension of what was being done or what was being added. And, maybe I didn't put the bow on this, but once you had documents into it, now you had this nice little workflow that was in a complete engineering package where you could ask for, a maturity increase or an approval to release of a CAD file and a drawing and a specification and a bill of material or parts list that went with it. And that pretty much covers everything that engineering needed to do.
However, as we know, engineering is not the only function within an organization. If you're going to create a product, it's not enough to just design it and have all the functional specifications. You have to go outside of engineering. You have to go downstream to manufacturing. You have to go to purchasing, et cetera. So is that part of where PDM was not enough and had to evolve? I mean, could it have continued to add functions? Did it need to go to PLM?
That's a great question. I think that has a lot to do with why PLM came into existence, right? So, we're trying to talk about how these are different. I think what you just said is where PLM comes in, that other people downstream need this data, need to use it, but they don't need to look at it in the way that the engineers look at it when they're creating it. They don't need that level of detail. They just don't think about it in the same way. So for PLM, when you talk about the life cycle and managing the other parts of the life cycle, that sort of implies the downstream. And in some ways, actually, it implies upstream, but that's another topic we can come back to. But I think it's where we start to look at how that PDM data gets used other places is what brings about PLM. A couple of places where that became obvious with PDM, yet one more thing that people did with PDM is they would try to integrate it with ERP because understandably, engineers looked at ERP and they're like, I don't know what that is. I don't know how to deal with that. So I know it needs my bill of material, but I don't know how to get it there. So lots of early PDM implementations tried to integrate to ERP with a bill of material. Now, turns out that was a force fit. And back in the day, not everyone understood that. It started to become clear because they realized why it was a force fit is the EBOM from PDM was not the MBOM or manufacturing bill that ERP needed. So it wasn't structured the same way, didn't have the right process steps, didn't consider the manufacturing process at all. So that, it started to highlight the fact that, well, PDM isn't exactly what the rest of the enterprise needs. And I think the other piece you mentioned about people is downstream, manufacturing goes to look at PDM and they're like, it's got some stuff in it I need, but man, that thing doesn't make a lot of sense to me. Or it's got more noise than what I need. And the same would be true for folks in quality or folks in purchasing who are like, look, I just need the drawing, And again, back in the day, we weren't...
Right. Or a nice picture or...
Right. We weren't modeling back then, right? Well, we were. We were modeling, but we weren't trying to send people our model-based definition. So,
right.
In amongst all this stuff, can I just have the drawing, please? So
that still gets asked sometimes.
Absolutely. It's still a relevant question.
So part of it's about the people, right? It's not just, from what you're saying, it's not just, PDM is focused primarily in engineering, whereas PLM is basically the entire organization. It's much broader than just engineering. So it's really, it's about the type of people that are using PDM versus PLM.
I think that's right. It can be. The place where it gets tricky, and not to confuse things while we're trying to clear them up, but PLM systems can also have a PDM function. So, this could get confusing in a minute, but let's just say, what is PLM beyond PDM, right? And I think it's the people thing that you just brought up is how we got there. Is PDM could take us so far and it worked well for engineering, but then when other folks needed things like a manufacturing BOM, for example, right? We just mentioned that an EBOM is not really what ERP needs to go execute and make the product. You need an MBOM. Okay, you need an MBOM. Where does that live? right? And we needed somewhere for it to live. Frankly, we need somewhere for it to live that's connected to the 𝙔OM because they're related. Everything that we've talked about so far, it's like one thing gets to the next, gets to the next, gets to the next. An 𝙔OM gets us to an emBOM. It's just reorganized, maybe has a few extra things or different things in it. Process plans are similar. Inspection plans. We have to think about tooling. So these things that are still product related or around the product and related to manufacturing, but where do they go? Does manufacturing need their own PDM? That wasn't really where we landed because it was all connected back to the product data set. So PLM grew out of, well, let's add more things for other people, for other groups, for other functions. There were more bills of material than just emBOMs, right? If you have a relatively sizable product and it's got a long life, it needs to be serviced, might need to be repaired or have spare parts, you might have a repair BOM or other types of BOMs that you need to manage. You've got other activities you need to do than just manufacturing. You need sourcing processes and they need data. So these are things that PLM started to add as capabilities because it didn't really make sense to add them to the PDM system. And the PDM system was pretty specialized. And, I can think of a few other things. Validation of the product is a big one. Lots of engineering gets involved in validation, but other groups do too. Even other groups inside of engineering, right? Whether if it's virtual validation through things like simulation, CFD and FEA and those kinds of things, or whether it's physical validation of the products being made in manufacturing, quality has a lot of data and plans and things that they need to address that connect back to that engineering definition. But they're different kinds of data, they're different things that they need to manage. I mentioned when we talked about downstream and people downstream that, there's upstream too. Let me throw in a few of those. How about on the early side of product development, requirements, right? I need to capture requirements. And in today's PLM systems, that's a big thing, right? That you don't see in PDM as a function, but is in PLM. And it's important. And it is part of that life cycle of the product. There's another thing that happens up front sometimes. Now, in terms of timeline, maybe it happens at the end, but in terms of when you think about the life of a product that's being sold, it happens early on. That's a configurator. If you have product lines and you have configured products or engineered to order products or something where there's this family of products and you're trying to decide which one or how it should be sized or, what market it's going to serve, that configurator needs to go somewhere, but it's not a purely engineering-driven thing. There are sales elements to that. There are market elements and marketing elements to that. Those are other things where PLM starts to be part of the picture because it just doesn't fit in PDM. It's just not an engineering only or engineering and CAD data focused kind of thing. So I think that's where we really differentiate them, right? The words data and lifecycle don't do it justice, but it's about how other parts of the enterprise, other people and the functions that they do, how that data needs to be connected back to product data, but it's different, it's unique. It needs to be related, but it's not exactly the definition.
So it's interesting listening to you talk through this. It's almost like PLM is the life cycle, not just of the product, but of the product data. So maybe we need a PDLM. I don't know.
Maybe that would have been a better one, right? Just add the L instead of trying to replace the D with the L. I agree.
Well, I mean, it certainly, PLM does certainly sound like an evolution, next stage, what have you, of PDM. But if that's the case, then we still have an awful lot of PDMs around. Matter of fact, a lot of the big PLM providers provide both PDM systems and PLM systems. And there are new PLM and PDM systems cropping up all the time. If PLM is an evolution of PDM, if it's bigger, if it's the next step, if it's the umbrella, why do we still have PDMs to begin with?
That's a great question. Is it just history that they're hanging around, or is there some other reason why they need to hang around? And I think it's a little bit of both. I mean, like you mentioned, I can give a case in point of 𝙀𝙀. 𝙀𝙀 still has, at least as we're recording the podcast now, still has a PDM product for SolidWorks.
Yeah.
And it came from Kinesio back in the day, years and years ago. and it's still around. And 𝙤𝙀, yeah, they have a different data manager in their PLM product, right? It came from Innovia, that came from Matrix, and now it's part of the 3D Experience platform. But why do they still have two? What's that about? And I think there's a couple things worth noting that tell us some of why they're around. Kinesio became so popular, and I think SolidWorks bought it because engineers loved it, right? So it was a good PDM tool. People really, they found it easy to use, and they liked it, and it was nice and simple and focused on the task at hand. So I think the key word, one of the key words here, is specialization. I think that's why some of these still hang around, not just history, but PDMs are specialized for the kinds of tasks and processes that engineers need to do when they're developing products. Whereas PLM systems, they're meant to help the enterprise with the life cycle of that product data, like you said a minute ago, PDLM. It's focused on the bigger picture. And so sometimes that means that the PDM function within a PLM isn't always as specialized. It's not as optimized for those users, those particular users. Now, that's not a fair generalization. Like the 𝙤𝙀 example I was giving a minute ago, they've done a good job of trying to learn from what that Kinesio product did that's now SolidWorks PDM. They really took that interface and they applied it to their legacy Innovia SolidWorks data manager, right? And they gave that PLM PDM function an overhaul and made it look like it. And so they've done a lot of things to try and get there. They did something similar with CATIA, where they leveraged the best of their sort of CAD data managers and tried to build that into PLM. So I think, the vendors are trying to get to the place where they can have the best of both worlds. But I do think it's the specialization that makes PDMs live on and still have a viable life. And maybe also the fact that some folks don't feel like they need the other parts of the life cycle, or maybe they might need them, but they're not ready for them yet, that kind of thing.
Right.
But I think that specialization is a big part of the answer.
So if PLM is a more general, a more umbrella type system, for the enterprise, focused on the enterprise, and PDM tends to be more specific, more for engineering or specific workflows. What about different types of data? What about, we talked primarily when we're talking about PDM, we're talking about MCAD. How is PDM type functions handled for electrical CAD? How are types of data managed for like simulation data?
I think that's a great point, Jen, that it's because it's specialized, what it means is there are different flavors of PDM. And this is maybe another reason why it has that ongoing life is PLM, when it tries to be everything to everyone, can struggle unless it specializes in all the areas that they need. So you brought up some good ones, right? Like the processes around ECAD are similar but different from MCAD, right? We're not making 3D models and putting them together in assemblies and creating drawings. Instead, we're doing a logical design that's a schematic, and then we're placing components in a board layout. Okay, that means that if you're placing components, really a big part of your design is about picking the right components. So there's a lot of math and logical simulation that goes on, and then there's a lot of work from libraries. That means that the PDMs for ECAD need to look different than the PDMs for MCAD. So specialized processes again. Same thing with simulation, right? If I'm managing simulation data, and a lot of folks will call that, SPDM, or in some cases SLM. I don't know that market well enough to really differentiate, but the idea is it's dealing with specialized processes there as well. You probably need to connect back to some of the CAD models, and then you might have other things that we didn't talk about as part of a PDM, like an optimization tool, right? A tool that can automate the simulation product and look at the result, and then if it's not within a certain range, run it again. And okay, that's a PDM kind of thing that isn't necessarily in the mechanical CAD or the electrical CAD PDMs that we're talking about. So I think your point's right on. Different types of data may need different types of PDMs because those processes are a bit different. And boy, there's a big one to talk about there when you think about what we're trying to do with PLM today and what kinds of products companies are making. It's not just mechanical and electrical. It's that plus code.
Right. Right. I think I told you I just bought a car for my daughter, and it has not only is it have a keyless lock and keyless start, but I have an app now. I can unlock her car. I can, I can check all of the data just from an application. How do you manage that kind of data?
Yeah. I mean, and to your point, the product you bought is inclusive of all the software in the car, the software that's on the app, probably the servers that help run the app and the IoT data. I mean, et cetera, right? This is the world we're living in where things are growing in complexity. So, what about PDM for code, right? I mean, if we've got PDM for MCAD and PDM for ECAD, what's PDM for code? And
wait, I know this one. That's source code control.
Nice. Nice.
I used to be a developer.
Yeah.
1,000 years ago.
You've lived this. You've lived this. And so that's it, right? Source code control is that. It developed out of the same things I was talking about for PDM for MCAD earlier, right? Like, we've got multiple files, we've got linkages, we've got versions of them, we need to compare. But it's the same as what we said a minute ago, where a source code and development is different in terms of process and specialization from ECAD and from MCAD and from simulation. Each one's got its own sort of special way that it happens. A great example, this is a fun one because it's coming up in the industry now. When we think about version control for software, we have fun things like branching and merging. And because it's a lot of, characters, ASCII characters in a file we're talking about, you can do comparisons and differences and merges and things like that. That's not so simple in the mechanical CAD world. But I will say that there are examples of it, right? I should give a shout out here to PTC and Onshape. Onshape lets you do that. Branching and merging and version control. That's kind of fun. And it's neat to see, concepts from one industry domain making their way into another one. So yeah, not to get too far down that rabbit hole, but it's yet another one. Source code control is another one where it's a different set of processes, it's specialized, and you need it. And so you might not try to do that in PLM. And actually, there's probably another good reason why you wouldn't do that in PLM. And that's because that industry, and I'm sure, with your background, Jen, you experienced this, it grew up its own PLM, right? So source code control, when it needed to interface with other groups outside of just the developers, said, well, if we've got requirements, if we've got documentation, if we've got testing, if we've got other things downstream and around that product development, we need systems for managing that. And so there's ALM instead of PLM, right? Application Lifecycle Management. But it just goes right back to optimization, right?
And this is starting to sound like our business systems podcast.
Yeah.
All of the
exactly
different
right.
systems. Yeah.
So yeah, when we realized that there's an ALM that fits with source code control that's similar to the way that PLM fits with PDM or multiple PDMs or SPDM or whatever it is, it's an interesting relationship. And it might even create some challenges. I think it does in a lot of companies about which one do you use. But it does at least make clear what we're trying to talk about in terms of the differentiation of PDM and PLM.
All right. So we've gone through and talked a little bit about a lot of things, right? So we've talked about PDM and PLM. You brought up source code control and ALM. Looking at the example of my daughter's car and all the software inside the app, et cetera. How does a company manage all of that? I mean, is PLM the system for that? Can you have PLM and ALM next to each other? Is there a way to connect them? What's the answer there?
That's the tough part, right? I mean, we were talking about PDM and PLM and said PLM is all the other stuff. And then as we talked about, how PDM is specialized, we got to that source code control and ALM and basically said, well, no, it's not everything. So
it's everything physical,
right,
maybe.
Right. But now what, right? And it's a great question. Could you do all the things you need to do to make that, connected app and car and all that stuff in PLM? And I don't think you can. I think, actually that example you gave is a perfect one. It's not a software product. It's not a hardware product. It is a system of systems, in fact, right? It's the app and the servers and the car itself and all of that. They're just systems upon systems. They all work together to give you what you want, to give you the product. So I think that's another interesting one, and that is systems engineering, right? We see this as a very hot topic today. Where does that get managed? So MBSE and the design of how that system of systems works, does that go in PLM or ALM? And a lot of times those tools have their own, I'll call it PDM. Maybe that's not fair. Maybe their own source code control, whatever you want to call it. But because their processes are unique, et cetera, all the things we've said, there's some specialized tools for it. But where does it go? I don't know. I think you need PLM. I think you need ALM. You need something to manage that systems data. And you probably need that systems data to be connected to both, right? Because the system is made up of the hardware and the software. And so it needs to tie to that other stuff.
There's integration and interoperability in there somewhere.
Absolutely, right? There has to be. If we're putting all of that stuff together, but we can't put it all in one system, we have to figure out how to tie it together in some way. So, I think we have to think about integration of the PDMs to each other, or the PDMs to the PLM, and the PLM to the ALM. And where the systems engineering fits, I don't know, but
I think we'll get there. I mean, if I have great confidence that the big PLM vendors are going to solve this. Matter of fact, if you look at, you had mentioned 𝙁𝑀, if you talk about Siemens and their low-code platform and how they're, working all of that in. So I think that there will be something beyond PLM.
Yeah. Well, maybe that's what they're all after, right? Each of them is sort of moving towards this platform mentality of, it's maybe services for the digital thread or whatever it is. Maybe you're right. There's PDM, there's PLM that expands it, and the next logical evolution is some kind of platform that encompasses everything. I don't know. Will they be successful? Who knows? But it does put context on the question we started with about, what's PDM and what's PLM and how are they different? There's something beyond PLM, and I don't know if there's a clear answer to it yet.
Yeah, here be dragons. So, we started with PDM. PLM is the natural evolution or expansion of. There may be something in the future, but bringing it back down to our users or our listeners, rather, that how do you decide which you need? Do I need PDM? Do I need PLM? Do I need them both? Where do I go from here?
It's a great question. It's not easy to, prescribe something in general. I think there are some things that can help guide people as they're asking themselves that question. There's one clear-cut answer here, which is if all you do is develop products and you're not actually trying to build them, maybe you could get away with PDM. Maybe, right? If you're just responsible for designing the product and developing its specifications and then saying, okay, that's it, I'm done, PDM might fit. And that could be true if, it's an electrical product or a mechanical product or even a software product, right? You just source code control and off we go. If you're doing more than that, though, then it gets tricky because the question becomes, do you want a PDM because it's highly optimized for what you do in product development and then connect that to a PLM so that, you can connect and share the product data and models and things like that with the rest of the enterprise, and the rest of the enterprise has a tool that's more suited to what they need more broadly? Or do you find a PLM system that has the PDM functions that you need so that maybe it's pre-integrated or ready to go? And there are those out there. There are PLM tools with great PDM capabilities in different domains. That's another possibility. Or, do you say, look, my biggest need is really around that data management aspect, and I deal with the life cycle aspects other places, right? Because there's some ERP systems that have good, decent PLM-like functions. So maybe you want a PDM or a couple PDMs, one for your mechanical, one for your electrical, that tie into your ERP. There are lots of, I think, patterns that people could follow in terms of what systems do I put in place? What's my enterprise architecture? And then you need to think about integrations. We mentioned that a second ago, how you tie them together. But I don't know that there's an easy, clear-cut, like, well, if this, then that, except for the one we just said about if you're only doing product development, product design, maybe you could get away with just PDM.
Right. So it definitely sounds like there's no one-size-fits-all sort of answer for this.
I think that's right.
It's highly dependent on what you do and how much of the product you do.
That's right. And where you see the value in your organization. I've worked with a number of companies that thought the answer was, well, obviously PLM. We do it all end to end. We have to have PLM. And then at the end of the day, they came to an answer of, actually, we'd be better off with multiple PDMs that are tied to sort of an umbrella PLM over top of it. And it had everything to do with how they operated as a business, even. We're a bunch of sort of semi-independent companies, and everybody has their own flavor of CAD, and they kind of operate, independently, locally, and we don't really share much. And those sorts of things, can drive the decision.
So when you're talking about like multiple PDMs, how to link things together, PDM versus PLM, at some point, I know we're about out of time today, but at some point, I'd really like to dig into the whole question of, is a monolithic platform the best way to go where, one system does everything, or is it better to have like best in breed and, basically have integrations that allow you to use the best tool for your business for the specific piece of it and then integrate all of them?
I think it is. It's the perpetual question of, is it best of breed, or is it something that's pre-integrated, monolithic, maybe handles all your needs? I don't know if we'll ever have a definitive answer to that question. I think the industry goes back and forth, and not just our industry, not just digital product. I think lots of software industries go either direction, but it's the way you get the answer for what you need today is just looking at your needs and trying to map it to what's available. So I don't think there is an answer to that one, Jen.
Well, it'll be an interesting topic sometime because it is one I'd like to dig into.
Well, at least, from the perspective of what we talked about today, hopefully we've given people a view of, that best of breed or that optimized piece. If you need a PDM that's really optimized to what you do, or a PLM that maybe handles the broader enterprise need. And as we're finishing with that kind of conversation about best of breed or monolithic, it's best not to go in with any preconceived notions that a PLM can't do the PDM kind of functions in a really optimal way. It might for you, right? So it's, as we're differentiating them, I just don't want to sell PLM short and say, oh, well, if you really want specialized, you have to do with PDM. It differentiates the two, but it doesn't mean that PLM can't do it.
Right. No, I agree. It's, defining what you need is the most important step as far as choosing which system or which platform or which tool is the right one for you.
So do you think we've cleared things up for people today? Or we just made a mess of it?
I think we've had an honest conversation about a very messy subject.
Good. I think it was fun. It was good going back down, in my mind, memory lane of how we got where we are, because I think it has a lot to do with how the two are different. And hopefully people have found it useful.
Right. All right. Well, thank you everybody for joining us today. And remember, like I said, every time, keep the conversation going. If you have questions, if you have either about this topic or if you have other topics you'd like us to explore, please let us know. And until next time, stay sharp.
See you, everybody.